Here I have a sine control test set up. I'm going to control on that control accelerometer at 2 Gs from 1280 Hertz to 1380 Hertz on an empty shaker table. If we look at the system drive, we can see that we have a very flat response across the frequency range. So now we'll go and control our 2G test. I'll hit ARM and start. And we get a nice 2G response all the way across the frequency range. Next, through the magic of time-lapse photography or videography, whatever you'd like to call it, we'll add a resonating object to our test stand and see how much more challenging it is to control. Now we've added a thin metal bar to our shaker table, and we're going to see the effects of changing different control parameters like compression factor and sweep rate on the test. Before we start our test, I'll hit start here on self-check, and with self-check we send out a low-level signal to characterize our control system. And guess what? When I look at the system FRF, probably right around 1330 Hertz here, I'm going to see a nice resonance from that bar. That was not there before when we were running without the bar and just the shaker tabletop. So there we can see that we have a resonant peak, and as it ends up, this resonant peak might be hard to control. So I'm going to arm the system. I got a 2 octave per minute sweep rate and a compression factor of 4. And we'll run our 2G test and see what happens. Oh, right where the cursor happened to be at 1330 Hertz, we got an abort because we could no longer control. There's 2 things that we could do to try and control better. One is to reduce the sweep rate, so sweep slower. So as soon as we start here, I will slow down the sweep rate by hitting the speed down button twice. We have a slower sweep rate. We were at 2 octaves per minute. Now we're at half an octave per minute. And we got through our resonance because the control algorithm had more time to update. Now it could be that for your test you cannot slow down the test due to your test specifications. In that case we could try something else. Instead of changing the sweep rate, we're going to change the compression factor. We went from 4 to 2 here. The compression factor controls how rapidly the amplitude can change. By lowering it, it's able to change the amplitude greater, and we can see that we got through our test. These parameters you can change in the main screen, but you can also change in your Sine setup screen as well. To understand how the number of periods estimator works, I'm going to change my control target level from 2 Gs to 0.2 Gs. So I'm going to try and test to a lower level, and notice my number of periods here is set to 1. Okay, we're ready to start our 0.2 G test. And you can see here it looks pretty good. Now if I zoom in a little bit, we can see that when we zoom in a lot, we can see that perhaps we didn't quite hit 0.2 Gs the whole time. And this is where the number of periods estimator can help out. So I'm going to go back here to Sine setup, and I'll increase my number of periods to 10. Then I'll get ready to run my test again. Before I run my test, I'll grab the results from my last test and I'll put them in the display. So there was our vibration level that didn't quite always match 0.2 Gs. Now I'm going to arm. I'll hit start. And we can see that the pink line here, where the number of periods was set to 10, matches the 0.2 G target level a lot better than the blue line did. And that's what the number of periods estimator can do for you. We've seen that test objects can have certain frequency ranges that can be challenging for control, and things like compression factor and sweep rate can be used to get past these difficult to control areas. Under the tabulated tab, we can go a step further. By picking tabulated, we can, let's say we had from 1300 Hertz to 1400 Hertz a hard to control area on our test structure, but otherwise up to 2000 Hertz it was straightforward. We can vary the compression factor as a function of frequency. So here, from 1300 Hertz to 1400 Hertz, we'll have a compression factor of 2, and we'll return to a compression factor of 4 once we're out of that area. Same thing with something like the number of periods estimator. By default, it's normally 1, but if I'd like to get more accurate control at some of these higher frequencies, for example, I can set the number of periods to be different at different frequency ranges. The software will automatically change this during the test for me.